Most people don't know this, but the SpaceX Falcon 9 rocket, which is now the most successful rocket that has ever flown, they did not have a customer for their first launch. They were trying to sell it for, this crazy discount, basically losing money on it, and they couldn't sell it. So they launched the first SpaceX Falcon 9 rocket with a chunk of aluminum on top, basically a giant aluminum block to simulate a satellite, because they couldn't get anybody to actually put a satellite on top of it. So we knew that would be hard, but too many rocket companies got funded in this last sort of boom of new space activity. The market for rocket launch is, there's just only so big of a market there. I was just very surprised. You can go look at the graphs, how much of the venture capital went into the rockets versus the spacecraft themselves, and it was pretty lopsided. I think we'll see that take care of itself.
Hey everyone, welcome. Thanks for joining us. We're gonna get started. I'm Nate Lowenthal. I think you all know me already. And we have with us today John Gedmark, an old and dear friend of mine and the CEO of Astranis. This is the first installment of Political Capital, which is a new conversation series that we're launching that will explore the intersection of technology, policy, and finance. We're really excited to have John here with us to kick it off. I'm going to ask him a couple of initial questions to get the conversation started, and then I will open it up for Q&A. So if folks have questions along the way, they can put it in chat, or I'll just call on you when we're at that portion of the conversation. So John, thanks again for joining us. I really appreciate it.
Thanks for having me.
So John, I've known you a long time. You studied physics and aerospace engineering at Purdue University. You got a master's in aerospace engineering at Stanford. You worked at the X Prize Foundation. You led the Commercial Spaceflight Federation, which is the industry trade association for the commercial space industry. And now you founded a satellite company. So I think it's fair to say you didn't drift into this orbit, but very much set out for it from the get-go. So when did you first know that you wanted to go to space, or at least shoot things into it?
Oh, since I was a little kid. My dad was a big fan of sci-fi books, and we had a giant bookshelf full of them in my house. I think when I was 8 or 9, started reading, some of the classics, Arthur C. Clarke, Robert Heinlein, Isaac Asimov. Yeah. So from the very beginning, I guess I would say.
I remember coming by the Astranis lab when it was a much smaller operation, and there was literally a blank metal table, and you had a half assembled satellite. And I was thinking to myself at the time, I can barely put together IKEA furniture, and you're building a satellite from scratch. What was that experience like? I mean, just having literally starting from a blank slate and trying to design something that would have to operate in space.
Oh, for sure. Yeah. It was a lot of fun doing, I tinkered with some of the early satellite designs, but quickly got out of that part of the business, or they kicked me out, and the engineers, that is, and have been running the company. But look, what I would say is it is surprisingly like any other startup, in that what really matters is what the customers want and what they care about. And so we ended up spending far more time than I think we probably expected, just talking with the future customers of our satellites and of our satellite capacity. So there's a couple of major conferences in our industry each year. One's in Washington, D.C., one's in Europe. There's a third one that's sort of a distant third that's in Asia. And so, you fly to these things, you sit down with prospective customers, and you're doing a ton in the course of doing that. So I would go do those trips and then come back and immediately, debrief with the engineering team. And to be honest, I still do that today. So just, I think, to give people a little bit of calibration, the company is about 300 people today. We're launching 5 satellites this year that represent between those 5 satellites, close to $500 million of future revenues that we have on contract. And yeah, I learn something every time I sit down with a new customer, and then come back and we work with the engineering team to figure out how to make improvements or tweaks to the latest design and go from there.
Would you say that the biggest challenge to the company was actually designing the satellites, or was that actually more pedestrian and it was really finding the customers and building the market?
Oh, there were no, it was all of it, all the above. Challenges on every front. Building the satellites was harder than we thought it would be. Our satellites are we haven't talked too much about the company, but our satellites are in a higher orbit called geostationary orbit, where so it's a special orbit where you can park a single satellite over a country and provide continuous service, broadband internet service. So very different from low Earth orbit satellites and satellite constellations, but it's structurally cheaper because you're just putting up the one satellite. You can provide this very low cost bandwidth, but it is harder. The satellites, it requires a lot more propulsion capability in order to get up into the higher orbits, and then once you're there, you're in this very harsh radiation environment, and all your electronics have to be basically rad hard to be able to survive this super harsh radiation environment. So that ended up being way harder than I think expected. Sales was definitely hard, but that was actually, I think we expected that, right? Selling a new aerospace product, an unproven aerospace product, is hard. I mean, most people don't know this, but the Falcon 9, SpaceX Falcon 9 rocket, which is now the most successful rocket that has ever flown, both I think technically and commercially, they did not have a customer for their first launch. They couldn't sell. They were trying to sell it for this crazy discount, basically losing money on it, and they couldn't sell it. So they launched the first SpaceX Falcon 9 rocket with a chunk of aluminum on top, basically a giant aluminum block to simulate a satellite, because they couldn't get anybody to actually put a satellite on top of it. So we knew that would be hard, but still very challenging. I think the part that actually has been the hardest compared to what I thought, I mean, fundraising we thought would be hard. We've raised a little over $500 million to date from private investors. We knew that would be hard. No, the biggest surprise I think was recruiting and hiring. But that's because there's been a boom of new hardware companies over the last few years who are competing for the same talent that we are. So that basically, that's sort of the supply and demand, relative supply and demand of hardware talent, hardware engineers, different from software engineers. Software engineers is its own thing in Silicon Valley, but hardware engineers, there's just been a huge amount of demand for that talent. So it's been a real fight all the way through to find the right people.
Even though you're building a new kind of satellite and you have to send it into space and you have to go sell to state and global governments your services, actually the hardest thing has just been building the team.
Well, it's really hard to say. It's hard to say what is the hardest, but I would say it was the thing that was the biggest, delta from what I expected.
Most unexpected challenge.
Most unexpected challenge, yeah. Was just how tough of a labor market for this specific type of or hardware engineers generally, as opposed to software engineers. But yeah, that part has been hard.
So let me ask about one other challenge I always wonder about with your industry. You mentioned the kind of trade shows in Washington, D.C. I mean, you can't remodel a kitchen in America without a permit. You guys are sending stuff into space. I have to imagine there's a pretty substantial policy overlay, and you have to navigate that, and maybe sometimes it's helpful and maybe sometimes it's a bit of an obstacle. What has your experience been like dealing with, I assume, mostly the federal government over the last couple of years?
Oh, well, great news there for us. It's been pretty smooth. So first of all, we only have to actually deal with the U.S. federal government if we are providing service in the United States, which we are with a couple of our satellites, but not all of them. Several of them are projects for other countries, and so the U.S. is not involved. We're dealing with spectrum rules through the International Telecommunications Union, but we do that through other countries. And then in the United States, we found it to be pretty smooth. I mean, I guess the thing is the world of geostationary satellites, has been a sort of very mature thing for a long time. It just historically was mainly these giant satellites, as opposed to our microsatellites, giant satellites used for broadcast satellite television. So this is where all the satellites are that provide satellite TV for hundreds of millions of households all over the world. And because of that, it's a very stable and mature regulatory regime. So we knew very early on exactly what rules we needed to follow, even though we're providing internet, not satellite TV, but still the same rules. And that was pretty straightforward. Yeah, that part was not challenging. Where we have had challenges with the federal government is actually in working with Space Force. And the ironic thing is that was like an inbound thing for us, right? We built this company to go bring low-cost internet to communities around the world, and that's what we're doing with our commercial business. But in the course of publicizing what we're doing and a lot of the new technology that we've built, people at Space Force found out about us and literally came knocking on the door and said, "Hey, we need help getting more capability up into space, because we basically have this new space race with China happening as we speak, and the potential for a conflict there." So they came to us, but in working with them, there are parts of there's been some success for sure, but there are real challenges in just doing basic contracting with the Department of Defense. We ended up finding a champion there named General Gutlein, who runs Space Systems Command, and he was able to move very quickly to get us on a contract. But that has been, the exception, unfortunately, not the rule there. So yeah, we got a lot of work to do on that front.
But you did get an initial contract recently with Space Force to help develop some of your systems.
Yes, correct. Yes, this is a $10 million contract for us to make some adaptations in basically new software for the satellite, for the software-defined radio on the satellite, that will allow our future satellites to support military comms, military communications over the same satellite design. So that's it's a stepping stone towards us fielding more satellites in the future for the U.S. military, for Space Force. But they wanted to get us off and rolling on some kind of initial contract, and so of course that starting with a smaller dollar contract.
Good foot in the door.
The foot in the door, yes, exactly. But even that, $10 million is not a lot of money in the scheme of things with the Department of Defense or the space industry, and but that took General Gutlein, a 3-star general who is responsible for, I think it's like an $11 billion annual budget, personally, saying this needs to happen and it needs to happen fast, and then his staff made it happen very quickly. But yeah, like I said, that's sort of the exception, not the rule, and I think we do need to fix things so that more companies like ours of Silicon Valley, can do helpful things for our national security.
Right. So you guys are sending these microsatellites into space, into geostationary orbit, more specifically, to provide internet to remote parts of the world. And you're competing against these more traditional, older school, school bus sized satellites that have been doing similar services. Where do you see the kind of satellite industry heading over the next couple of years? I mean, are you the sort of tip of the spear, and this is where everyone's going to be moving?
Oh, no, I'm not aware of others actually successfully following us on this front. The legacy satellite operators seem to continue to be charging ahead, doing things the same old way, and I think we will find that that ultimately is not successful. And meanwhile, there's us with our approach with small satellites in GEO for many applications, and then there's the low Earth orbit satellite constellations like Starlink serving more direct to consumer and other applications. And between us two low Earth orbit constellations and us providing dedicated satellites with very low cost capacity for some enterprise customers, I don't know there's going to be a lot of room for the legacy big geo satellite way of doing things, but we'll see. They seem committed to their path that they're on, and they don't seem to be changing. So we'll see what happens.
Great. Let's open up for questions. Barney, I think you had a question.
Yeah, very interesting presentation. Thank you. Tell me more about the rockets you use to get up there, because I'm wondering whether, because you're reaching so much higher, I presume there are fewer rockets that make that journey, but is that an issue, sort of finding space and negotiating to get your satellites up to that high in orbit?
Yeah, it's true. There are less, but still a couple dozen launches a year to GEO today. Okay. So for our first launch, which is coming up very soon, actually, our first satellite is at Cape Canaveral as we speak. I just got back from there where I went to go see it get integrated onto the rocket. So that satellite is flying on a Falcon Heavy. So that Falcon Heavy is launching a big GEO satellite, and we're flying alongside as what we call a rideshare payload. So there are opportunities like that, and then but we're launching 5 satellites this year. So after this first satellite, we're actually going to launch 4 more, and those 4 more we're launching together as a 4-pack on a Falcon 9 rocket that we bought for ourselves. So we just went and bought a whole Falcon 9 rocket just for us. Wow. And we're putting 4 satellites on top of it. And the way it works is these same true for us as for other as for the big satellites, is these the rockets that launch to GEO don't actually take you all the way to GEO. They take you to what's called a GEO transfer orbit, which is sort of part of the way to GEO. And then you have to get the rest of the way there yourself with onboard propulsion. So I mentioned some of the challenges of building satellites earlier. One of the challenges was figuring out a propulsion architecture for the satellites that, in our case, combines an electric propulsion system and small chemical thrusters that allows us to do that ourselves as a small satellite. It used to be that really only big satellites had that capability to do that orbit raise up to GEO. But we have an ion thruster on board that we will, that we turn on shortly after the satellite gets separated from the rocket, and we use that to do our own propulsive maneuvers to get up to GEO.
But a Falcon rocket, who builds them? And do you basically you hire a crew to operate and actually fire the rocket? I mean, how does that work?
Oh, no. SpaceX builds the Falcon 9 rocket, and they operate
this is their. So it's Falcon. Okay, SpaceX that you're contract. Okay.
That's right. That's right. Yes. And they provide, this launch as a service, right? I mean, you just show up at the satellite and in advance, obviously, how you're going to mate it to the rocket, but you show up and your team does the mating operation to the rocket and they take it from there. It's their rockets, they launch them, they fly them, they recover them because they're now, landing the boosters and reusing them. They take care of all of that. Yeah.
What I didn't realize was they did geosynchronous, I thought they were just low orbit craft. I didn't realize that they went that much higher. Okay. And then, but you bought this one, so you'll be able to, you'll whatever is recovered, you reuse yourself, and to you that makes sense to do rather than leasing from or lease from them for all their own futures.
Oh, when I say we got our own, I mean we got our own dedicated rocket, but we're not buying it in that they're not handing us the keys. They still
okay. That's what I inferred from what you said. Yeah. Okay.
Yeah.
Your
But all rockets can go to geo, essentially. I mean, all of the major rocket families, and that's because historically, actually, geo is the most profitable and valuable sort of piece of real estate in the solar system, right? The space industry was actually mainly built on the commercial success of satellite television. And all of the satellite TV satellites, right, are in geo. So there's primarily been a huge, historically been this big demand for many launches. Well, many in space terms, a couple dozen launches to geo per year on the commercial side, and then also on the military and national security side as well. A lot of the sort of very important national security missions that we do are with big satellites, geo. And those are some of the biggest satellites that have ever been built, and they cost several $1 billion per satellite, and those are all in geo.
Right. Okay. Good. Thank you.
Go ahead, Scott.
Yeah, really interesting presentation. Thank you so much for taking the time. I'm curious, is there any overlap between what you're doing and what Starlink does? And is there any sense of competition between you and SpaceX, or is that an issue at all?
There's a little bit of overlap. I mean, we really are focused on enterprise applications and providing backhaul and trunking capacity for telcos, right? That's sort of our main business area, and they focus on really direct to consumer applications. As you can or can go buy or at least get on a wait list to get get service for your house if you want. So it's two very different business models there. Where we've seen some overlap is in mobility applications, so in-flight Wi-Fi, maritime, so like cruise ships. So we've been doing some competing there. I guess what I'd say is our capacity is significantly cheaper. So for customers who really care about sort of bottom line, low cost, we tend to win those competitions.
And really curious too, like, is there, because I don't know anything about your industry, what's the life cycle issues that you have to deal with? Like, how do you think about what happens to your satellites eventually in the end? And yeah, and then, because I don't want to hog the time, I just want to thank you for my son who works on fishing boats in Alaska. So I know you signed the contract with Alaska. It's super cool.
Yeah, that's great. Now we'll definitely be providing some more service for boats in Alaska. I'm sorry, what was the first question again?
Oh, first question is just life cycle of a satellite. Like, how do you?
Oh, yes. Yeah, sorry. I mean, in space, you can think of it as low orbit and high orbit applications. In low Earth orbit, those satellites, by international regulation and treaty, need to be re-entered, right? And they burn up in the Earth's atmosphere at the end of their life. In higher orbits, it's different. It would be too difficult and expensive and possibly even dangerous to other spacecraft to bring things back once you've already gone through all the effort to get up to these high orbits. And so what has been defined again through international treaty is what we call the graveyard orbit. And the graveyard orbit is an orbit even farther out, where basically there is a permanent belt of space junk that we agreed is just where we're going to park the old stuff, and everybody knows where that is and how to avoid it.
So your satellite needs to have enough fuel or whatever left at the end of its life to push itself further out into space where it can then live for eternity.
Correct. Yes. Yeah. A lot of the there's some regulations around this, and a lot of it is like how much extra fuel you have to make sure you have available at the end of life to make sure you can actually successfully do that last maneuver. Yeah, there's some things around that.
Other questions? Go ahead, Dylan.
Yeah, thanks, John, for your time. Just quick question on kind of the thought of build versus buy when you guys were starting out. Did you always plan on making your own satellites, and then kind of going in the future, do you see yourself manufacturing satellites for other companies or strictly for Astranis?
Yeah, I mean, we always planned to do the satellites ourselves because there's no one else doing it, right? I mean, going to an existing company, and there's no one that really, I mean, the small satellites for GEO did not exist. So the only people that would have been capable of doing it technically would be like Boeing or Lockheed Martin, but they would have wanted, $1 billion. I mean, it's a ludicrous amount of money to do that for you. As for the future, no, we do not have plans to build satellites for anyone else. I think we have looked at hosting payloads on our satellites if we're sending up satellites to go up and do, our normal missions, and we could have something right along on them. But building the satellite for someone else where we hand over the keys and they have control over it, I don't think really works with the model, since a lot of the efficiencies are in us, building large numbers of these. We know exactly what we're building. They're basically all the same, and we're building them on an assembly line, and we operate them all out of one mission operations center. One mission control with software that we can use to fly the whole fleet in an automated way. That starts to break down if you start doing these other cases.
Cool, thanks.
I have one final question, but if anyone else in the audience has a question, you should jump in right now.
Hey, John, thank you for an excellent presentation. This is Mark Sauter with Pickwick Capital. You've done a great job of raising capital for your company. Where do you think the VCs and other debt providers are overinvested in space, and where are they underinvested?
Underinvested, you mean aside from Astranis, since obviously we would generate massive returns for our investors. Okay. No, very seriously, too many rocket companies got funded in this last sort of boom of new space activity. Not because they're not good, they may be technically sound, but the market for rocket launch is, there's just only so big of a market there. There's only so many satellites to be launched, and you're competing with rockets that are on this global stage. You have rockets built by the Europeans, by the Chinese, by the Indians. There's also Chinese and Russian rockets, which we don't, which U.S. companies can't use, but still, there's only a need for so many rockets. Underinvested, I would say, is honestly everything else. I mean, all the things that you can do from space that provide value and provide some actual benefit and help to a person here on Earth. That's what it's all about. And I was just very surprised. You can go look at the graphs, how much of the venture capital went into the rockets versus the spacecraft themselves, and it was pretty lopsided. So I think we'll see that a correction there. I think we'll see that take care of itself.
Thank you.
Awesome, John. Well, we're at time. Thank you so much for joining us for this conversation. We really, really appreciate it. And best of luck with all your work. And we'll talk soon.
Thank you very much. Thanks again for having me, Nate.
Bye,
Great
everyone.
chatting with you. Thank you, everyone. All right. Bye-bye.